Hello, my name is Andy Hales at the University of Mississippi, and in this video we are going to learn how to compute a new variable in R. Now, the example we're going to be using is from pretty typical psychology data where you might take several Likert items and average them together into a scale. And this is going to involve three steps. We need to reverse code the appropriate items, check the reliability, and then observe the new result. So let's look at an example of this. So say we're dealing with a scale like this. So participants might complete this survey and they answer these 6 items where they rate on a 1 to 7 Likert scale the extent to which they agree: I feel good about myself, I feel like I belong, I feel invisible, I feel like I have no control, I feel angry, and I feel sad. So this is what we're working with. The first thing I want you to notice right now is 2 of these are positive and 4 of them are negative. And our goal here is to create a single composite score for everyone where we can call this well-being, just overall well-being. And I'd like to set it up so that higher scores are a good thing. So let's go into R and look at how we can do that. So here we're going to be using the usual tidyverse package and also a new one called Psych, and that's going to let us check the reliability of the scale using this Cronbach's alpha measure. So go ahead and install and load those, and we'll also read in the data. And here, like I have been, I'm selecting the columns that we're going to be working with, and we can go ahead and take a look at this. Again, I've kept this column here indicating participant ID number. We don't really need it, but no reason not to have it there. It just feels like an organized thing to do. And then we have 1 column each corresponding to each of the items that we were just looking at. So we can see our first participant had a score of 6 on the first self-esteem item, a score of 6 on the next item, which was I felt like I belonged. Those are high scores. This person's feeling pretty good. But then if you look at the what's called here current meaning, that was the item I feel invisible. Now this person doesn't feel very invisible. They scored a 2 out of 7. And the control item was I feel like I have no control. And this person disagreed with that item. Again, that kind of indicates they're feeling pretty good overall. They don't feel very angry. They don't feel very sad. Great. So this is the data we're dealing with. We have that information for most of our 49 cases, but there's some missing values in there, which is pretty typical. Psychology data is messy. So let's go through those 3 steps I mentioned. The first thing we need to do is arrange this so that across all 6 of these variables, we want higher scores to be a good thing, not a bad thing. And the way we do that is by reverse coding. So for the items that are negatively worded, we want to go through and make it so that every 1 becomes a 7, every 2 becomes a 6, every 3 becomes a 5. The 4 is the midpoint. That can stay the same, and so on. And when we've finished doing this, it'll be the case that all of the items have been recoded so that they're all pointing in the same direction. So here's how we're going to do this in R. We're going to take our data, and notice we're using the assignment operator here. So what I'm going to do is I'm going to perform these operations, and that's going to update or save over our data file. So we're going to take data and we're going to mutate. In other words, we're going to take these columns and calculate new things. And take a look at the first column, which is, again, we can remind ourselves that's current self-esteem and belonging don't need to be recoded, but current meaning does. So that's where we'll start here. And so we're going to take current meaning, and here, for starters, we're going to use this case when function to tell it that for cases when the current meaning equals 1, we want you to change that to 7. And for cases when current meaning equals 2, we want you to change it to 6, and so on. And if you do that, you will successfully reverse code the data. That works, nothing wrong with it. It does take up quite a bit of space, so if you're in the mood to use a convenient shortcut, it happens to be the case that when you have Likert data like this, you can also apply a quick formula to achieve the same result as reverse coding. If you have a 1 to 7 scale, if you take the number greater than the number of response options you have, in this case 8, and subtract the original score, well, that gives you the identical result to reverse coding. So, for example, if someone had a score of 7, well, 8 minus 7 is 1, and so the 7 becomes a 1, just like you would want. So for these next 3 columns, I'm going to achieve the same result using our little shortcut here. Now, a word of warning, if you do get in the habit of using that shortcut, you need to make sure to update it if you're working with Likert scales that have a different number of response options. If you have a 1 to 5 scale, you need to use 6 minus the current value. So let's go ahead and run this, and when I do, I just updated the values of our columns. Now, we don't have a different number of columns. I didn't create new columns. The reason for that is because the variable names here are identical to what they were before. So I'm essentially saving over those columns. Now, again, our original data is fine. What happens in R stays in R. So I've saved over it as far as our current R session is concerned. If I wanted to give these variables different names, I could do that. I could call this current meaning underscore reversed, and that could be a way to indicate for me that it's a new variable. That's dealer's choice on how you want to handle it, but it is something you want to pay attention to. All right, now that we have our reversed items, since we're here, let's actually just confirm that they were reversed. You might remember our first participant had scores of 6, 6, and then 2s, and now that is 6, 6, and then 6s. So the 2s became 6s like we would want through reverse coding. So the next step is to check the reliability. There are a lot of ways to do this. We're going to use Cronbach's alpha. Cronbach's alpha is, to overly simplify, it's an index of how well correlated these items are. And our scale is at least reliable if these 6 items on average are highly correlated with each other. Doesn't necessarily mean it's a good scale, it doesn't mean it's a valid scale, but at least it means that these items are coherent. They make sense together, they're correlated together. And the way we do that in R is we take our data frame and we tell it we want to select just these 6 columns that are part of our Likert responses here. So that's going to leave out the participant ID column. We don't need that, that's not part of the scale here. So we're selecting just the scale columns. And then we're feeding that to this alpha function from the psych package. And that is going to give us Cronbach's alpha and a bunch of other outputs. So let's take a look at this here. You can see all the way up at the top, we have the raw alpha value of 0.86. So that is our Cronbach's alpha. 0.86 is pretty good. People like to come up with cutoffs for this. I'm not even going to name any. It's obviously higher is better, and very few people would worry that 0.86 is too low. So off to a good start. It seems like these are a reliable scale. One other thing that can be really useful when you're computing a reliability like this is to scroll down a little bit and look at this output here, reliability if an item is dropped. So here this is imagining if you were to get rid of an item, a single item, and leave the others the same, how would that affect your scale? And what you want to keep an eye out for here is if you have a bad item, it could be the case that if that item were removed, your reliability would get much better. That can be a sign that maybe you forgot to reverse code an item, or that the item is just simply not a good part of your measure. Now, in our case, we can see all of the Cronbach's alphas, if we were to get rid of any one of these items, are lower than the Cronbach's alpha that we actually have. In other words, no red flags here. These all seem to be okay. Now, if there were one where Cronbach's alpha were a little bit higher if we got rid of it, that's not necessarily a catastrophe. You know, we could still use our judgment. However, this is a really good piece of information to use overall when you're making that judgment. So we've reversed our items. We've confirmed the scale's reliable. It's time to compute the thing and check out the distribution. So to compute the new scale, again, we're going to take our data set and we're going to update it. So we're using the assignment operator here. So we take our data and then we apply this little row-wise function. Don't worry too much about what that's doing. It's just telling us that what we're going to do next, we want to do for each row. And then we're using mutate to create a brand new column. I'm calling this current well-being. Current well-being is equal to the mean of all 6 items. And remember, meaning, control, anger, and sadness, those have been reversed. And I'm telling it to do that, and it can go ahead and ignore missing cases where relevant. And so when we run that, now instead of 8 variables, we have 7. Or I'm sorry, instead of 7, we have 8. And we can see our 8th variable is this current well-being, which is computed as the average of all 6 columns. And so for our first participant here, who happened to have 6s across the board, his or her average is, of course, 6. All right, so now that we have this new variable, we can look at the histogram, and we can compute summary statistics. Look at that. Most people have pretty high current well-being. That's good news. I'm glad to see most people are in a good mood here. And we've got the mean, median. You can see the last video for details on how to generate descriptive statistics. But for now, you know how to create brand new variables from scale data in R. So we'll go ahead and pick up next time.